welcome. Today we're looking at Euler's number. I know it looks like Eulers, but his name is pronounced Euler. And continuous exponential functions. So the thing to remember about Euler is he came up with this constant, and this constant is very helpful when used as a base in exponential calculations. So he just found that this number represented growth of continuous functions very well. Notice also that it says squiggly lines there, meaning that it's an approximate. It's a number, it's a constant, meaning it doesn't change, but it's a constant in the sense that pi is a constant. Like it goes on and on forever, but it doesn't end. It doesn't repeat. So yeah, it's one of those numbers. It's a very special number that helps us do a lot of calculations in math. So the first thing we want to do is we want to be able to calculate this. So we're going to be using a calculator to do these first two problems. We're rounding to the nearest thousandth, which is the third decimal place. So let's just go ahead and do it. We should be able to find E on our calculator pretty easily. So our E is this button over here on the left hand side towards the bottom. And we're doing 175 e to the 0.5. So we're going to do 175. We're going to hit our E. And then to do our exponent again, we're going to do x to the y. And we're going to do 0.5. We're going to hit equals. And we're just rounding this number to the nearest thousand. So 288,526. 288,526. Again, we're using these squiggly lines rather than an equal sign because we've rounded that number. It's not the exact value. All right, same thing with number 2, e to the negative 0.35. So we're going to hit our E button again. X to the Y, negative 0.35. And we get 0.705 because we're rounding it up. So we have the 6 next door to the 4, 0.705. And we're using the squiggly lines again because we rounded. It's not an exact answer. Okay, so just some work on getting you comfortable with using the calculator to find these answers and how to round properly. This is also another calculator exercise. So one way you might find E is in one of these functions where it's in the denominator, and we have this t here. These can model population growths. You'll see them in science, at higher levels of science. You'll see them in pre-calc and in calculus eventually if you guys get there. But this one is just straightforward. It's asking us to find the initial amount and the amount after 9 years. So the key to initial amount is this is what happens at time 0. So what is the P of 0? Meaning if we take our t and plug in a 0 there, what is our answer? So we have 2200 over 1 plus 7e to the negative to the negative 0.15 times 0. Right? So all we're doing is plugging our 0 in for our t. Okay, so let's plug this into the calculator. It's going to be a little bit messy. In fact, let me write it down so I don't forget. It's a lot of numbers there. Okay. So what we're going to do here is we're going to do 2200 divided by, we're going to put a parentheses here, and this parentheses is going to hold in everything on the bottom. So we're going to have 1 plus 7 e to the, I'm going to put another parentheses in here because there's two things that we're multiplying in that exponent on the bottom. Parentheses negative 0.15 times 0. And then I'm closing the next parentheses. All right, so make sure all the parentheses are closed. Every open parentheses has a closed parentheses to go with it. And then we're going to hit our equal sign. and we end up with 275. All right, so the initial population was 275. So if we're talking about deer, that means we started off with 275 deer. If we're talking about cats or dogs, that just means that that's the amount we started with. At time 0, that's how many of that thing we had. All right, same idea. What is the amount after 9 years? So everything else is the same, except for our time now is 9. Okay, let's plug this all in. 2200 divided by parentheses, right, for the whole, for the whole denominator. 1 plus 7e to the, again, we're going to put parentheses in there because we have a multiplication, negative 0.15 times, this time we have 9 years. We're going to close out both parentheses. I'm going to hit equal, and we have 781 point, well, it doesn't say what to round to, but if we're talking about animals, we probably should round to the whole animal. We shouldn't have like a decimal of an animal running around there. So 782 deer or cats or dogs or mice or whatever you want to think about. Okay, so just working with this form, making sure you guys can use your calculators properly. Yeah, pretty straightforward. Plug in, use your calculator. All right, so now we're talking about word problems. Some of us don't like word problems because we don't understand how to use them or how to figure them out, what numbers go where. So we're going to try to make it a little bit simpler on you. So in this case, it says we have 782 grams of a chemical. Find its mass after 6 hours if it decreases at 12% per hour. So that we're going to underline all the important things here. So it's going to be going for 6 hours, right? It's decreasing, and this is the rate that's decreasing. So when we're looking at continuously, I don't want to say compounded, but a continuously calculating exponential function, right? It's actually a little bit easier than the compound growth function because there's less variables in here. So the initial amount still comes out in front. That's our a sub 0. E is a constant, right? That's not going to change. The rate is our r. Keep in mind that our rate always needs to be converted to a decimal, and then the t is the time. So it's really easy. The one thing to note here, though, is that the growth is if our rate is greater than 0. Our decay is if our rate is less than 0. All right, so what we're doing here is we're going to do... we're going to start plugging stuff in. Let me change my colors here. So we start with A equals the initial amount, which is 872 grams. E doesn't change. E we do because it's constantly, in this case, decreasing. Right, our rate is 12%, so let's change this. We're going to move it to a decimal, and because it's decreasing, we're going to say negative 0.12. If it were increasing, we'd say positive 0.12. All right, so very important that we note, is it decreasing or is it increasing? If it's decreasing, it's a negative rate. If it's increasing, it's a positive rate. That's what we said down here. And then how many hours did we grow for? 6 hours, so times 6. All right, let me write this down again. So 872e to the negative 0.2 times 6. All right, let's see how much we decreased. So 872e to the, and because I'm going to put two things in there, when I do to the, I'm going to put a parentheses. Our rate is negative 0.12 times 6 hours, and then we end up with 424.4 424 as our mass after 6 hours. So it's kind of decreasing a lot, right? It's losing 12% per hour. So whatever chemical you have like less than half of what you started with after 6 hours. All right, so some of you guys who do chemistry, you guys do know that there are things that decay, that are decreasing. You're gonna have less of what you had to begin with as time passes by. All right, let's apply the same idea to continuously compounded interest when you're investing. So I'm not sure if there's things that continuously compound. I heard there are, but I'm not sure specifically what. But technically, it's compounding every moment. It's continuously compounding rather than every day they recalculate, or every month, or every year, or quarterly. They're doing it all the time, constantly. So it's kind of crazy. But all right, let's say we invested $1,100. So this is going to be our initial, right? The rate is 7%. Compounded continuously tells us that we need to use the E formula, right? We're not going to use the regular compounding one for that. And then we have 3 years. So let's set this thing up again. Okay, so let's plug stuff in. Our initial amount we're investing is $1,100. We have E to the rate. This time we're growing, right? We're investing money. We're getting more money each time. So it's going to be positive. And let's move our decimal place. Be careful with that. It's easy to just put 0.7, but it's going to be 0.07 times 3 years. Okay, so let's plug that in. Invested $1,100. E to the, our rate was 0.07 over 3 years. Oops, I made a mistake again there. Put our parentheses, it's not going to register correctly. Over 3 years. $1,357.05. 1357.05. Okay, so that's it. The form is a little bit easier to work with for continuously compounded things. Just remember from this lesson, E is a constant. It's approximately 2.71. And we don't even actually have to memorize that like we did pi, because our calculators have the E button on it and we really don't have to write it out. But just for future reference. And yeah, just work with the word problems. Make sure you're plugging in the correct values in the correct places. Also remember that for these problems, growth is positive. So if our amount is growing, we want to put a positive rate. If it's decaying, meaning we have less, like we did with the problem with the chemical stuff, then it's going to be a negative rate. Other than that, it should be pretty straightforward. Make sure you work through with the calculator. You get super comfortable. If you have a scientific calculator or a graphing calculator, you should be able to plug it in like we did in Google, in the Google calculator. I just like to use that one because I figure all of us have a Chromebook in front of us. We can use that to calculate, but most of them will work the same. The one that's weird is the iPhone one. It's like an old school scientific calculator where it does not do order of operations. So you can use it for sure, but it's going to be harder, and you're going to have to really think about where you put your parentheses and store stuff. It's kind of a mess. So I would advise you, if you do have one that you can type it out like we did in Google, use those if you have it on hand. Be comfortable with it. Otherwise, Google Calculator is perfectly fine. I'm just gonna try to suggest to not use your phone calculator if you have an iPhone. Android works fine. It works like the other ones. If you want to, maybe you can download an app that works a little bit better on your phone if it's free. You can try them out, see if they work okay. But again, make sure your notes are taken. Make sure if you have any questions that you write them down so we can go over them next class. Good job today.